Welcome back to Aurora Tech Channel. Today, I will be reviewing a huge machine, the Comgrow T500. This is a final prototype from Comgrow, and the retail version may have some minor changes, but I will just base my review on my personal first-hand experience with the machine that I received. Many of you may not have heard of Comgrow. They're one of Creality's resellers who have been selling thousands of Creality printers on Amazon for many years. Previously, I reviewed their laser engraver, the Z1, and the mini desktop CNC. The T500 is their first 3D printer, and it's an interesting choice to start with something at this size, but let's take a look at what you can get from the T500. As its name suggests, the print volume of this large bed slinger is a 500mm cube, which is bigger than anything I have reviewed before. The total weight of the machine is over 80 pounds. The motion system uses modular linear rails on the X, dual Y, and dual Z axes. There are two brackets made of solid aluminum at the back to enhance the rigidity of the tall gantry. The print surface is a spring steel sticker sheet, and a Meanwell 600-watt PSU is used to heat up the huge bed. The machine runs Klipper, and it uses a 7-inch touchpad that's pretty similar to a Sonic pad as its touchscreen. The Linux OS and Klipper are actually installed on the pad. The 32-bit motherboard is used to connect the stepper motors, limit switches, and the print head, while all the processing is handled by the 7-inch pad. The hardware of the pad isn't specified on their product page, but as it's from MakerBase, I believe it's a MakerBase 7-inch pad that runs on a quad-core Cortex A53 processor with 1GB RAM and 8GB eMMC, which is pretty standard configuration for a Klipper pad. There is a 6.5:1 ratio dual-gear direct extruder, and although the heater block is a Volcano-style one, it's using a non-Volcano-style nozzle. It comes with 3 extra hardened steel nozzles sized at 0.4, 0.6, and 0.8 millimeters. For other small details, the belt tension can be adjusted using a hex wrench on every linear module, and the filament roller is all metal with an adjustable screw to control the smoothness of the bearing inside. With all these hardware components, this machine is priced at around $900. I would like to thank Comgrow for sending us this machine to review, but before we get started, I would also like to thank VOXELPLA PLA for sponsoring today's video. VOXELPLA PLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA PLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500mm per second while maintaining a flow rate of up to 25mm³ per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA PLA Pro is also affordable at just $16.99 for a 1kg roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors, as well as the Vision Enclosure Kit that includes all the necessary parts to fully enclose your BambuLab P1P. For more information, please visit voxelpla.com. The machine comes with a large box that weighs almost 90 pounds. All the parts are well protected by laser-cut foam, and even though the machine is huge, the components are pretty simple. It's a typical bed slinger, but everything is just bigger. We have a fully assembled base with dual Y-axis modular linear rails, the gantry with the dual Z-axis, the X-axis, and the print head. There are also 2 brackets to reinforce the gantry, a 7-inch Klipper pad, the screen mount, filament holder, power cord, a toolbox, user manual, and a roll of sample filament. Like all other bed slingers, you just put the gantry on the base. The good thing is the screws were tightened from the top, so you don't have to flip this heavy printer and tighten them from the bottom. Put the brackets at the back to reinforce the gantry, mount the spool holder on top, and mount the screen bracket on the right side. When I compare the screen to a regular 4.3-inch touchscreen, it looks huge, but it doesn't seem all that big on this T500. There's also a ribbon cable with a cable chain, so we just need to put it on top of the gantry and connect some cables, including the print head, X-axis motor and limit switch, the dual Z-axis motors, and 2 cables for the screen. Finally, flip to your local voltage with the power supply at the back. Let's turn on the machine. I'm happy to see this standard Klipper screen. Personally, I prefer this more than any self-developed UI by different manufacturers. I will start with Auto Home to make sure the stepper motors, limit switches, and the inductive bed leveling sensor are all working. Then go to the leveling menu. Z-calibrate means Z-offset in Klipper, Z-tilt means gantry leveling, and bed mesh means auto leveling. I will start by setting the Z-offset with the paper test. As there is no leveling knob underneath the bed, and we don't have to adjust the bed corners. Next, I will let it level the gantry. Finally, I will do a round of auto bed leveling. It's going to probe 49 points on the bed. Okay, the setup is now done. Let's start with a simple benchy. The USB drive comes with a skin Cura. I will just add the Comgrow T500, and there are 2 of them. I'm not sure which is which, so I will just randomly pick one. Let's take a look at the print profile. The default layer height is 0.2 millimeters, the print speed is set to 180 millimeters per second, the walls are being printed from 140 to 160 millimeters per second. The top and bottom are 100, the first layer is 40, and the acceleration is set to 3000 and 1000 for the first layer. Let's take a look at the extruder. The retraction distance is 0.5, and the speed is 40 millimeters per second. So everything seems pretty reasonable. Let's slice a benchy. The estimated time is 33 minutes. I think there's no way that printing at 180 millimeters per second will finish a benchy in 33 minutes, but let's connect the Moonraker plugin and send the print job to the machine. Type in the machine's IP address, check the Ultimaker format thumbnail, and we can upload it to the printer and start the print. Let's do a sound test. I place the meter a few inches away from the machine. It stays in the low 60s in decibels and occasionally jumps to the mid 60s. I will let it finish and then see the time and print quality. The print finishes in 43 minutes, which is 10 minutes longer than the estimated time and is more in line with my expectations from a 180 print speed. The quality is pretty decent for a fast machine, with good cooling and just a bit of stringing. However, I had issues with removing the print from the bed and accidentally damaged it. I talked to Comgrow about this, and I will discuss this more later. But for now, I will just apply some glue to the bed to work as a release agent to continue my testing. I will then print a number slider to test the clearance. As you can see, I've applied some glue to the bed to avoid causing further damage to the print surface. The print finishes in 3 hours and 17 minutes, which is almost an hour over the estimated time. There is some stringing, and using this clear color for the number slider, the numbers are hard to see. However, the clearance is good, so the slider is very smooth. Then, I will test the retraction of the extruder by printing my Honeycomb box, which has tiny patterns on all sides. There is more stringing than I would prefer, but all of the patterns were printed successfully. Let's do a comparison to other new generation machines. It's not the best or the worst. I would say it's a pretty average print compared to all other machines. Next, I will print the Robo Alpaka from Prusa and compare its print quality with other machines. It took 5 hours and 48 minutes, which is way longer than the estimated time from the slicer. Let's do a comparison to other new generation machines. When comparing it to the Ender 3 V3 SE, which also printed this model at 180mm per second, the print speeds are pretty much the same, but the print quality on this T500 is better. Compared to the fastest machine that has printed this model so far, which is the AnyCubic Kobra 2, the Kobra 2 offers better quality and print speed. In comparison to the Creality K1, the print quality is similar, but the K1 is faster. In comparison to the BambuLab P1P, the P1P provides better print quality and faster speed. Lastly, when compared to the AnkerMake M5C, the print quality of the AnkerMake is slightly better, but the T500 is faster. I will then switch to a 0.8mm nozzle to print a large lampshade. The height of the lampshade reaches the machine's maximum at 500mm. Since the maximum flow rate of this hot end is approximately 30mm³ per second, when converted to a 0.8mm nozzle, it reaches about 58.5mm per second. So, I will set the print speed to 50mm per second, and the first layer is now printing at 25mm per second. The print starts at 25mm per second for the first layer, and it has no issues. Once it starts to print the wall, it speeds up to 50mm per second, which also looks fine. However, I can see some overhanging at the lower half of these squares having a minor cooling issue. The top half of these squares print better than the lower half. I will try to slow it down to 50% of the speed at 25mm per second and see if there is any difference. The clarity of the filament does look better when printing slower, but it seems the top half is still better than the lower half, and slowing it down doesn't make a huge difference. Anyways, I do like the clarity when printing at a slower speed, and it would also be better as a lampshade. So, I will just print at a slower speed and let it finish. Okay, it appears that both the extruder and hot end can maintain a 50mm per second speed, as I didn't see any under extrusion issues on a print speed of either 25 or 50mm per second. But the bottom half of the square still shows some minor cooling issues on the overhanging part. The print took 12.5 hours to finish, which is way longer than the estimated time since I slowed it down to 25mm per second. Despite some cooling issues on the bottom half of the squares, the lampshade still looks cool, and I'm quite happy with this print. Then, I will print a kitchen towel hanger using PETG, since the maximum bed temperature of this machine only reaches up to 80 degrees Celsius. The print finished in 1 hour and 35 minutes, displaying typical PETG characteristics with minimal stringing. It is fully functional and I have no complaints. Next, I will print a TPU wallet. I will set the print speed to 50mm per second for everything, including the first layer and walls. This 6.5:1 dual gear direct extruder also handled it very well, and the extrusion was perfect. Finally, I will print with some nylon carbon fiber. I had stored a few rolls of nylon and nylon combination filaments in the new SUNLU S4 filament dryer in storage mode. Before using them, I also heated them up at 70 degrees Celsius for another hour to ensure that the PACF was in good condition. The result is very nice. The layers look good, and the print is fully functional. So for nylon carbon fiber, if the filament is dry enough, you really don't need anything fancy. Any machine with a hardened steel nozzle at 260 to 270 degrees Celsius works just fine. Let's talk about the pros and cons of this printer, starting with the pros. 1. The motion system is excellent. It uses modular linear rails on the X, dual Y, and dual Z axis, making it almost as good as the 3000 Snapmaker Artisan in terms of the motion system. 2. The frame is super rigid. There are no issues even with this huge 500 by 500 print bed swinging back and forth, and the 500mm tall gantry is also sturdy. 3. The Z-axis is supported by dual Z modules with 2 independent stepper drivers, so Klipper can use the inductive bed leveling sensor to level the gantry. There are 2 manual knobs at the top. When the machine is off, you can still manually move the gantry up and down for nozzle changing or other maintenance. 4. The print speed is fairly fast, printing at 180 mm per second with a 3000 mm per second squared acceleration at a 0.2 mm layer height. Printing a standard quality 0.2 mm layer height benchy in 43 minutes is reasonable, considering this large bed slinger can't move as fast as a small printer. 5. The print quality is decent. It passes all the tests, including clearance and retraction. For decorative prints like the Robo Alpaka, the result is in line with other latest generation machines. 6. The firmware uses open source Klipper, and the screen is a standard Klipper screen. You can have SSH and root access using the default maker-based Pi login and password. For the web interface, it also uses the standard Fluid. This decision is actually smarter than what some other manufacturers choose by trying to modify Klipper firmware or create their own touchscreen UI and framing it as their own self-developed system. This often ends up with buggy firmware, a bad UI, and it overall ruins the user experience. 7. The print bed is big, but it can still heat up within a reasonable time frame. The machine comes with a 600-watt Meanwell power supply. Heating from room temperature of about 25 degrees Celsius to 50 degrees Celsius requires around 4.5 minutes. Heating to 60 degrees Celsius requires 7 minutes, 70 degrees Celsius requires 10 minutes, and 80 degrees Celsius requires 16 minutes. The temperature difference from the center to the edges is around 7 to 13 degrees, which is acceptable for a bed of this size. 8. The filament holder has a bearing and a screw for adjusting smoothness. It can feed the filament smoothly without causing it to roll back and create filament tangles. Now for the cons. 1. The main issue I've encountered with this printer is related to the print surface. It sticks too well to PLA, and the adhesive used to attach the print surface to the steel sheet is pretty weak. As a result, the print surface detaches from the steel sheet and tears or peels off when a print is being removed. However, after glue is applied, the printer works perfectly fine. 2. The nozzle's maximum temperature is 300 degrees Celsius, but the maximum bed temperature is 80 degrees Celsius. You won't be able to print ABS, ASA, or polycarbonate, as these materials typically require a heated bed temperature of 100 degrees Celsius or higher. 3. The cooling is sufficient when printing with a 0.4mm nozzle, but when using a 0.8mm nozzle, the extruder is pushing out much more filament. Printing at 50 mL per second with a 0.88mm line width and a 0.64mm layer height results in a flow rate of close to the hot end's limit of 30 mm³ per second. Both the hot end and extruder can keep up, but the overhang on the bottom half of the square is not as good as the top half. This is mainly due to insufficient cooling, and this was confirmed when I slowed down the print to 50% of the original speed and still saw no improvement. 4. The location of the filament sensor could be improved. It would be better if it were integrated into the print head. Currently, it's positioned 1 to 2 inches above the print head, which can be kind of obstructive when feeding in filament. 5. The input shaper was pre-calibrated in the factory, and I didn't recalibrate it as my FL-Sun V400 machine has also been using pre-calibrated values for a year and hasn't encountered any issues. It seems that this T500 is a similar case, but when you need to attach an accelerometer, you still need to use screws and attach it to the print head. Using CAN bus with one single cable and integrating the accelerometer in the print head, like many other new generation machines, would be a better option. 6. Since the machine I received is still a prototype, there are some quality control issues. For example, 2 of the screw threads were defective, and the heat cartridge cable was disconnected when the machine arrived, so at first, the nozzle couldn't heat up. When I opened the printhead cover for inspection, I found that the heat cartridge cable had come loose even though hot glue had been applied. This issue was mainly caused by the cable being too short and the zip tie being too tight, causing it to pull on the cable and detach the connector. In conclusion, the hardware of this printer is solid. It uses modular linear rails on all axes, and it's very uncommon to see this kind of motion system on a 3D printer. I've only encountered a similar motion system on another $3,000 machine I reviewed, the Snapmaker Artisan. While the small details on the Snapmaker are better, the actual cost of the linear modules for both machines are similar. Considering that the T500 is priced at around $900, with this motion system, 7-inch Klipper pad, and 600-watt mean-well power supply, the hardware itself is well worth the price. The print speed and print quality are satisfactory, and the print volume is enormous. So, I would say this machine has a lot of potential, and the overall value is also pretty good. The quality issues I saw were reported to Comgrow, and they assured me that they have addressed them and will conduct detailed inspections during large-scale production. Regarding the print surface, they explained that the one on my testing machine was manually glued and attached, but for large-scale production, all of them will be processed by machines, producing more consistent results. As I haven't had the chance to evaluate a final large-batch production version of the T500, I can't confidently place this machine on my recommendation list just yet. Currently, only 7 out of 100 machines I've tested have made it to my list of recommendations on AuroraTechChannel.com. If I find that their large batch production has addressed all of the quality issues, I will definitely consider adding it to my list. In any case, I've put a link to the Comgrow T500 in the video description. That's it for today's video. If you found it useful, please hit the like button and consider subscribing to our channel. Thank you for watching, and I will see you next time.